Okay, so on the graph. Y equals 3 to the x. Now, context. Okay. That's just to give you a context. The graph of 3 to the x is going to look a lot like the graph of 2 to the x, which you know how to construct. And you construct it without even using numbers. Okay. Now, early in the semester, we saw that the graph 2 to the x matches. Of course, this is a 4x4 rectangle with a red dot here. Then here is x equals -2. Here's x equals 2. And up here is y equals 4. And we could list the coordinates of these points. The coordinates of these points, if you just analyze, you know, and label the lines. Here's a line y equals 2. Here's a line y equals 1. Y equals 1/2. Y equals 1/4. X equals -2. X equals -1. X equals 0, etc. But the construction get 4, 1, 0, 1, 4. But of course, by the calculations. Two to the -2. Sorry, 2 squared. Sorry, -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And you've done this. If you've done it using a calculator, you really haven't learned it. Unless you already have really good arithmetic skills and number sense. Okay. So all this is just context of comparison what to do here. Now, if you got y equals 3 to the x, we could do calculations. But the subdivisions wouldn't be half. You'd be subdividing things into 3 parts, and that just doesn't work out well. So what we do is take you know, when I put this stuff down, doesn't make any sense at all. Let's do this again. You get 1/4, 1/2, 1, 2, 4. Then you calculate this 2 to the -2, which I should have done originally, is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the second is 4. Okay. So that would be a table for 2 to the x. That was 2 to the x squared, because I wasn't thinking about what to do. Anyhow, we want to do y equals 3 to the x. Well, we get 3 to the -2, which is 1/3 squared, which is 1/9. You don't want to use the calculator to do this. We have to understand negative exponents. We have to understand that this is what we get. And also Open Math does things with decimals. Well, sometimes you need to do that, but with the whole number to the x, you don't need to use decimals. Okay, anyhow. 3 to the negative 1 is 1 over 3 to the 1, which is 1/3. 3 to the 0 is 1, 3 to the 1 is 3. 3 to the second is 9. So when we sketch the graph, here's a line where x equals 2. On this line, x equals -2. Up here, y equals 9. This horizontal line. And now we can start sketching points. When x is 2, y is 9. So we have this point. When x is 1, which occurs here, y is 3. Where's 3? If 9 is up here, where's 3? Well, it's twice as close to this, to the x-axis, as it is to the y equals 9 line. Y equals 9 line. You could mark off. You can space lines here. So you get y equals 3 at this point. So x equals 1, y equals 3 is there. X equals 0, you get y equals 1. Where's 1? 3 is here, and 1 is down about here. You get this point. When x equals -1, y is 1/3. Well, this is 1, 1/3 is pretty close to the x-axis. When x is -2, y is 1/9. That's real close to the x-axis. Now we have a graph of y equals 3 to the x. So we could do this using a table. That's legitimate. If we want to do 3 to the negative x, that will list our x values, -2, -1, 0, 1, 2. Same x values that we get when we subdivide our 4x4 square. So that we can compare the way the graphs that we get. Well, we can compare the graphs that we get with the graph of our toolkit exponential function. You see that we have a very similar curve. Okay, so if we make a table here, I'm going to put a column for negative x, which is 2, 1, 0, -1, -2. So if x is 2, negative x is, if x is -2, negative x is 2. If -1, negative x was 1, and so forth. So now we have 3 to the negative x would be 3 to the second, which is 9. And so forth. Now, if you do this using a calculator, you're not going to be as likely to see the connections between these values and these values. If you do the calculations, that's going to trigger some recognition of how these values compare to these values. If you use a graphing calculator to do it, you don't learn much of anything. Well, now we see this. Okay. Now I'm going to draw a line for y equals 3, a line for y equals 6, and a line for y equals 9. And these lines should be about equally spaced. This one's a little too close to the x-axis, but we're gonna just kind of live with it. Okay, when x is -2, y is 9, so we're gonna put y here. When x is -1, I'm not gonna label this line, this is x equals -1. We should know that, okay? We get y equals 3. Now, we gotta have a line for y equals 1. Which might be about here. And that goes with x equals 0. And now when x equals 1, we're gonna get y equals 1/3. Where's 1/3? 3 times as close to the x-axis as 1. Okay, if this is how far we are, this is how far 1 is from the x-axis, then that's about 3 times as close. And 3 to the -2 is 1/9, so when x equals 2, y equals 1/9. It's going to be 9 times as close to the x-axis as y equals 1, which is going to be down here practically on the x-axis, but not exactly. And we're going to have then curve looks like this. Now, if we want to do y equals 2 to the x plus 3, we can make a table. But let's just go do it up here. Using our 4x4 rectangle. So again, I'm sketching the graph of y equals 2 to the x. Now I want to do y equals 2 to the x plus 3. I just lift this graph up 3 units. Now where's 3? Well, this line is y equals 4. This line was y equals 2. This wasn't a construction line for a graph of 2 to the x, but it's going to be handy to have it here. Here's y equals 3. Now, what's good about y equals 3? Well, we just raise this graph up here, and now we draw the identical curve and raise every point 3 units. So every point goes up 3 units. This point will go to here, this point will go to here, this point will be here. And there's a picture, and that's y equals 2 to the x plus 3 is vertically shifted. The graph of y equals 2 to the x. Vertical shift is 3 units. So this is how you need to understand these graphs of y equals b to the x. You need to make the tables and do the actual arithmetic without a calculator. Now, if it's y equals 0.48 to the x, well, you're going to use a calculator to do powers of 0.48. But if it's a whole number or a fraction with a whole number denominator, you do the arithmetic by hand. And you need to do that. Okay. Okay, here's our graph of y equals 3. Here's the table for y equals 3 to the x. You have 1/9, 1/3, 1, 3, and 9. Now I'm going to make a table. Remember when we did inverse functions? We switched the numbers in the columns. So if we switch the columns, we have 1/9, 2, we have 1/3, -1, we have 0, 1, we have 1, 3. Okay. Uh, okay. So -2, -1, 0, 1, 2 goes over in the Y column. 1/9, 1/3, 1, 3, 9 goes in the X column. This is the inverse function. Okay. And so first X equals, let's go down to X equals 2. Sorry, X equals 9. Uh, myself on root. X equals 9 goes out here. So it equals 9. X equals 3 and X equals 6. We don't really need X equals 6. We just need to divide things up pretty evenly. There's X equals 9. We need X equals 3. Because it's in the X column. And X equals 1. And then you need, we can actually do X equals 1/3. X equals 1/9 is too close to the Y-axis to really draw. So I'm not going to try to draw a line with that. But we'll figure out what to do in a minute. Okay, so Y values go from -2 to 2. So I'm going to put Y equals -2 here. And I'm going to put Y equals 2 up here. So that Y equals -1 be here. Y equals 1 be here. And now I've got all the points that I need, except that the 1/9 -2. Squeeze that one in. Okay, so let's see, when X equals 9, Y is 2. That puts point here. When X equals 3, Y equals 1. So that's going to give us a point here. When X equals 1, Y equals 0. That's going to give us this point. When X equals 1/3, Y is -1. So that's going to give us a point here. And then when X is 1/9, Y is -2. Now, if this is where X equals 1/3, 1/9 is 3 times closer to the X-axis, so it's going to be some point about here. And now we can sketch graph of Y equals I haven't said what the name of this function is, okay? And I think we should have done this. Okay, so I'm going to call my 3 to the X function f of X. My function here is the inverse function, f inverse of X. So for f of x equals 3 to the x, this graph shows y equals f inverse of x. And f inverse of x is log base 3 of x. Now, last time we looked at the rules for solving exponential and logarithmic equations. And what we said was that b to the a equals c is equivalent to log base b of c equals a. Let's just see how this relates to the graphs. We get negative 1/3 because 3 to the negative 1 equals 1/3. Now, if 3 to the negative 1 equals 1/3, that's of this form, isn't it? B is 3, A is negative 1, and C is 1/3, right? Okay. Now, y equals f inverse of x. I've just given it a name. I said this is log base 3 of x. Now, if 3 to the negative 1 is 1/3, by this rule, log base 3 of 1/3 should equal negative 1. Well, if x is 1/3, log base 3 of x is negative 1. So this line says that log base 3 1/3 is negative 1. So that this line says exactly the same thing as this line. Except that, of course, the graph looks like this. Now, the graph of 3 to the x, as we saw earlier, looks like this. It looks pretty much like the graph of a 2 to the x function, your basic exponential function. This function is a reflection of that function through the line where y equals x. Now I'm going to leave it to open math to show you that. Okay. So this is where the rule for solving logarithmic equations comes from, and how you construct the graph of the log function. Not by punching buttons on a graphing calculator, by drawing, by making the table for the exponential function and switching columns. Okay. Then we have a tangible understanding of this graph. Okay. And okay, now logarithms have some important properties. If you add logs of A, you add the log of A to the log of B, you get the same thing as if you is the log of A times. That's a rule analogous and exponential, or a rule of exponents. And that applies to log with any base. Okay. And this is kind of related to the idea that, like A to the X times A to the Y equals A to the X plus Y. When you multiply some number and to you multiply a power of A times another power of A, you add the powers, and it should be clear why that's true. For example, A squared times A cubed equals A times A multiplied by A times A times A, which is A to the fifth, which is A to the 2 plus 3. And we went over that to some extent earlier in the course. Okay, so you have to know these rules. You have to be able to kind of reason them out and distinguish rules that look the same, that look very similar, and are easily confused. And we'll talk about that in any case. Here, you're doing a multiplication and essentially getting an addition of the exponents, right? Just like here's where a multiplication gives you an addition. Here, an addition gives you a multiplication. Okay? So this rule comes from this rule. Okay. The other one is I want to change my letters here. Same rule. Instead of capital A and capital B, I'm just going to use X and Y. Okay. Same rule, just using X and Y instead of A and B. Because I just realized having a B for the base and a capital B up here could be confusing. Okay, so now I'm going to say that A log base B of X equals log base B of X raised to the A power. A here, we can use A here. So I did some change this exponent here. P power. Okay. Now this is analogous. It says A to the X raised to the Y equals A to the X times Y. On this side, you're raising something to a power. On this side, you're multiplying the powers. Well, here, you're multiplying by P. And over here, you're raising your X to the power. So you see, you have a raising to a power and a multiplication. Here you have a multiplication and a raising to the power. So you should maybe think about how these rules might relate. And the whole thing is not that difficult to explain just by looking at what happens to columns when you reverse them. But we're not going to get into that. We're just going to use the rules. Okay, now, those are really the only rules you need. But there's another one that's handed that follows these two. That is that If you subtract two logs to base b, it's going to be the log of this one divided by this. Okay, so rules are not difficult. Use. Well, we're going to do now an application of these rules. We have log of x plus 3 added to log of x minus 2. Which one of these rules, first, second, or third rule applies? Say, how many turns? Yeah, one. Okay. And I thought that's okay. One. Okay. Yeah. So right out, what do we get? What does the rule tell you? First rule tells us that the log of x plus a log of y is a log of x times y, right? So here we have a log of, that means log of one thing plus a log of another is the log of the product of those two things. So we have a log of x plus 3 and a log of x minus 2. That has to equal the log of x plus 3 times x minus 2. Okay. Now, there's another one. And you know, these rules for logarithms, you need to practice them. You need to get used to them, okay, to really become pretty natural. And you got to remember these, and you will if you do a bunch of problems, okay? Okay, well, let's take an equation. Okay, yeah, let's take it. Let's do log base 2. Let's say log base 2 of x plus 1 plus the log base 2 of 2x minus 3 equals 4. Now, you can't do anything with that 4, but you can do plenty with the left-hand side, right? And it's the same thing that we did here. We're just gonna write this as a log base 2 of x plus 1 times 2x minus 3 equals 4. Now, can you change this to exponential form? Because we want to solve this for x. Remember, we've got this rule that allows us to convert from log form to exponential form, or from exponential form to log form. So can you convert this to exponential form? We'll have to convert it to exponential form in order to get to x, because x is all bound up in an expression within the log base 2. And you can't get to it that way. You can get to it if you reverse the forms. Take a minute, see if you can write that out. Okay, so we're doing pretty well with this. People take two different approaches to this. Some people want to go ahead and multiply this out, and you're going to get 2x squared and minus x minus 3 equals 4. Now, I would suggest they convert it to exponential form directly from here. But there's no reason you can't do this, because you're gonna have to multiply those things out anyway. Now, how do you put this into exponential form? Well, if it's in this form, b equals 2, c equals 4, a equals 2x squared minus x minus 3. So we get 2 raised to the 4th equals 2x squared minus x minus 3. Now that's an equation you can solve. What kind of an equation is that? Don't answer yet. Okay, so we identify this as a quadratic equation because you have the square on the x and everything. Two to the 4th is 16. A perfectly good quadratic equation. You're going to probably need to solve this using the quadratic formula. Okay, so I can write this out. You know, this is 2x squared minus x minus 19 equals 0. And from this point, you use the quadratic formula. So this equation can become 2x squared minus x minus 19 equals 0 by these steps. And you're going to get x equals 1 plus or minus the square root of, let's see, you're going to get 1 squared, you're going to get negative 38, so 4 times that is 152. So you get 153, I think, over 4. So I'm going to even turn the crank and do the quadratic form. Check my numbers there. Okay. And if you're rusty in the quadratic formula, get out the rust. It's easy to use. Okay, so again, we've seen that this equation give you this equation, which has a solution that I think is this. Check my numbers. Okay. Let's take this equation. What can we do? What rule or rules apply to this equation? Well, think about it for a minute. What's the first rule you're going to need to apply? 1, 2, or 3? Okay, you're going to naturally want to apply the rule we just applied, and that's the good instinct, except it's not going to work. What are you going to do about that too? Okay, there's no number in front of either of these logs. This doesn't tell you what to do if you got a number in front. You go to rule 2 first, and then you're going to do rule 1. Okay, so write out what you get. Okay, so we can't apply rule 1 because rule 1 doesn't address what happens if you've got a number in front of the log, and you've got a number in front of this log. Okay, we'd have to have just plain old logs before we can apply rule 1. Rule 2 allows us to take this number out in front and make it the exponent. Okay, so 2 log of x, according to this rule, if p is 2, we have 2 log base b of x equals log base b of x squared. So this becomes, and let's stick with log base 2 because it's easy to 2 powers of 2. Let's be log base 2 of x squared plus log base 2 of x minus 1 equals 3. And now we can apply rule 1. Tells us that's going to be log base 2 of this times this. And now, we could multiply this out, but we'll leave it factor. And I'm just gonna go ahead and convert to exponential form. So that 2 to the third equals x squared times x minus 1. Well, 2 to the third is 8, so we get x squared times x minus 1 equals 8. Now, at this stage, this is probably hard to solve. It'd be a cubic equation and no easy path. Okay? So that might be a difficult equation to solve. So we're not going to address that. We're just trying to learn how to apply the logs. Okay. Okay, again, rules are over there, if you're watching this. And not in class, you won't be able to see it, so go back and write them down. Can we apply the rules to simplify this? Okay, give you a hint. It's going to be, okay, well, if I gave you log of xy, you could write that as log x plus log y, couldn't you? Okay. So we're expanding the logs. If you go from here, if you're given an expression like this, you can contract the logs. You can combine these two logs into the log of a single expression. Okay. If you were given a single log, you could very likely expand it like so. Okay. So let's see what you can do. Let's see what rule you can apply. Okay. So you can pick one rule to apply. Okay, well, okay. Look like you're a little stuck. So if I leave chalk, I could write this as the log of x squared plus the log of y cubed over 2 to the 4th. I mean, this is x squared times y cubed over z to the 4th, right? So a log of product of two things is the sum of those two logs. Okay. Now, what could I do with the log of y cubed over z to the 4th? Okay, you can apply rule 2, right? Okay, and if you apply rule 2, looks like that was not recorded. But log of x squared, that's not the rules 2 log of x. Log of y cubed by the second rule is 3 log y. And the log of z to the 4th is 4 log z. So again, we can expand a logarithmic expression. Sometimes we want to do that. Or we can contract a logarithmic expression as we did with this equation. Or with that equation. Okay? And if we're solving equations, it usually ends up contracting logarithmic expressions. Okay. So again, homework follows very closely with what we did last time and what we've done this time. Okay. So shouldn't be too difficult. These assignments don't usually give people a lot of trouble if they practice enough and remember the rules. So when they take a test, you know what the rules are. Okay. Okay, well, very good.